This is Team 6, Week 4 group project. This presentation will compare two automated tools that can be used for data cleaning and data quality improvement. That is, statistical data editing tools and error prevention tools to improve data quality. To give you a general idea of what we're about to discuss, I'm going to highlight the two different tools in which data cleaning takes place. That is through data editing and error prevention tools. Data editing is a method of analyzing data to discover patterns of rules in order to identify data exceptions to those rules. And error prevention tools are an end-to-end system that improves data quality and efficiency at the point of entry. Data editing is a method of analyzing data to discover patterns of rules, to identify data exceptions to those rules. Business rules, also called edit rules, are closely related to the integrity constraints, entity integrity and basic integrity. Data editing involves automated computerized checking of data against constraints on the data. This can be as simple as checking a single data field, more than one field, or as complicated as a probability. Once an error is detected, replacement occurs. An example is replacing commonly occurring words with a single spelling, or replacing words in fields which are compared to lookup tables to get standardized spelling, or a specific word, for example, ink, to incorporated. Going hand in hand with data editing is data cleansing methods. Data cleansing can target finding duplicates within files or across files. Data cleansing is used to identify duplicates when unique identifiers are unavailable. It relies primarily on matching of names, addresses, and other non-unique identifiers. Error prevention tools are end-to-end systems that can improve data quality and efficiency at the point of entry. Dynamic forms build probabilistic models from existing data based on erroneous entries, so these dynamic forms can re-ask and reformulate posed questions in order to verify their correctness. This is an error prevention technique that simplifies the question in a way that reduces the chances of a data entry worker making an error. This mechanism predicts the most likely answer to a reformulated question. These probabilistic mechanisms make sure that responses are as complete and accurate as possible while data entry is taking place. The form dynamically adapts to the values being entered by providing real-time interface feedback. Error detection is straightforward. Questions whose responses are unexpected with respect to the rest of the known input responses are more likely to be incorrect. These error likelihoods are measured both during and after the entry of a single form instance. These generalized defect prevention products let you define business rules and invoke them from applications updating the data. Error prevention tools demonstrate how quality can be assured at data entry and form design. Poor organization, user interfaces are often at the root of the data quality issues. With data editing in a data warehouse situation, the ease of implementing or data edit rules with specialized theorems can be dramatic. The speed of which analyzing data against a set of business rules to discover inconsistencies is tremendous over the more manual processes. These edit rules are built into tables and in many systems can assure that all records comply with these edit rules without human intervention. There are several low-cost and easy-to-use rule discovery products that discover both quantitative and qualitative rules. However, with all good qualities, it falls short. This is an after-the-fact solution. Bad data makes it into the database. It can be very costly and time-consuming to clean dirty data. Editing is conducted downstream from the creation of data values, and improvements are not sustained. Error prevention tools enforces integrity rules at the source of the data. Products are invoked from applications where they can produce executable models that test data as it is inputted. Error prevention tools have the potential to improve data quality at reduced cost. A more intelligent user interface is one that can reformulate questions. Reformulation can enable streamlining of the input interface, improving data entry throughout. Skip logic is designed to prevent erroneous questions from being asked in the first place or prevent a full version of a question to appear. However, the downside with reformulation is that entry forms may cost more to complete. Studies have shown that both entry time and error rate increase as a function of interface complexity. Another drawback to question reformulation in dynamic form, error prevention tools, is that it reduces the number of possible responses presented to the data entry worker. It is impossible for the reformulated questions to capture all possible legitimate responses. An argument can be made that data editing and data cleansing are just not enough. This is a process that will need to be repeated as dirty data is reintroduced to the database. We can also say that although error prevention tools have a probabilistic mechanism, which is usually at the core of the system, that can analyze the data at input time and determine if the data entered makes sense, regardless of the business rules or integrity constraints surrounding the data, they can never take the place of being able to fully identify, audit, edit, and deduplicate and scrub data elements of a database. Error prevention tools are not a substitute for data cleaning tools and therefore still not enough. Arguments can be made that improvements of data quality is not in data editing nor in data cleansing, but in the development of processes that identify the root causes of erroneous data. For idea data quality, applying process management to data and shifting the focus to the process that creates the data values and the faults within that process is more valuable. Proactively using the results of data editing through applying process management to the data is more useful than simply correcting errors. The volume of information gathering by companies shows no signs of slowing down. In fact, the rate of increase in data gathering is astronomical in the last 10 years, especially with the advent of social media. At this pace, a typical company can have tens of millions of records. We foresee a shift in focus to a more preventative method of managing data quality, with data cleaning as a secondary and complementary focus. We believe firms will approach data quality proactively and not reactively, preventing dirty data from infiltrating the database. Intelligent and dynamic form design will be the future in software application development. This will be an expected and necessary feature like combo boxes. We expect to see intelligent and dynamic form design to be the norm in user interface in the future and not the exception. A data quality plan will not only be about cleaning the data, for preventing dirty data. Both quality methods will always be used together, working hand in hand, because we believe data quality will not be achieved without one or the other.